Hi there, welcome. In this video, I'm going to explain you a new module that I've been creating the past months, and that is to create an automatic air-to-ground defense mechanism. Now within this presentation I am actually using some NATO symbols. I'm not going to go in details about the NATO symbols, but the slide is self-explanatory. Just have a look, maybe freeze the video and maybe look at some of the symbols that are being used further within the presentation. So what is then air-to-ground dispatching? Well, the new air-to-ground dispatching mechanisms are implemented by the new AI A2G dispatcher class. It is a new defense mechanism that will dispatch airborne squadrons towards an exact location within the battlefield where enemy targets are being detected. A command setter is coordinating these efforts and is communicating the actions towards the players. And the detected targets are being detected by a detection network set up for different reconnaissance vehicles. At the end of this video, I'm going to show you a demonstration mission and explain you the exact stuff that's happening as a demo. But for the moment, bear with me because I need to explain you a couple of essential components, otherwise you won't understand the video that I'm going to show you. So let's talk about the detection class first. The detection class implements the detection mechanism. So you need to deploy within your mission a couple of friendly reconnaissance units, and there are two kinds of them. You can have the detection being done by reconnaissance vehicles or airborne aircraft like helicopters or airplanes that are detecting targets from the air. Depending on the onboard detection, let's say technology that is being enabled, the targets will be detected very close by or from far away. And you really need to be careful which aircraft or which vehicles you actually deploy within your mission to detect the enemy targets. And I will go a bit more in detail on the specifics of the units for the two coalitions. Now, the detection classes will actually detect the targets and will then group the detected targets within areas. And depending on the kind of detection class that you enable, the area formation will be different. So the detection areas will group the enemies within circular areas, by example. So once you got some areas being detected, then those areas are being reported to a command center. And that command center is actually also a real vehicle within your mission and is being implemented through the command center class. The other component of the air-to-ground dispatcher is you'll need to set up a couple of squadrons that are affiliated within air bases. Now, squadrons can be created in multiple compositions. Squadrons are allocated towards an airbase, and you can have multiple squadrons being allocated to the same airbase. In this case, when a defense action is needed, it will select the required squadron for the defined defense action. Another aspect of squadrons is that a squadron can be defined using different types of templates of aircraft. So you can choose the templates yourself using the mission editor, and you can have different airplane types, or you would be able to use the same airplane type but then have different templates to model different liveries or skins or different payload compositions. Another aspect of squadrons is that they have a resource management database. So you can allocate a specific amount of resources to a squadron, or you can make unlimited resources available for the squadron. Just remember that squadrons is all about templates, and those templates are defined using the mission editor of DCS World. Let's talk about the next component of the defense mechanism. A very important component there is the defense point. And defense points are actual locations or points within the battlefield that are being used to define where the defense areas are being located. So the defense mechanism will evaluate from the defense point or coordinate where the enemy locations are, and will then dispatch squadrons to engage depending on the urgency of the defense. So let's reiterate how this thing is working. So you got Wrecker, in this case an AFAC airborne, detecting enemy target locations and is reporting those locations to a command center. That command center will dispatch a squadron that will then command to engage on a target. Now the question is, when exactly is that dispatching happening? Well, the mechanism for the dispatching is based on a model, a mathematical model, and depends on the distance from where the enemy targets were detected. The distance is evaluated from the different defense points that you have set up within your air-to-ground dispatcher defense mechanism towards the enemy target areas. The further away the enemy targets were located, the lower the probability will be that that target area will be engaged upon by a defending squadron. The closer by, the higher the probability will be. Now, a defense point or defense coordinate has a limit, which is a range around each defense coordinate from where there will be any engagement to a detected area. So in this case, this detected area, that target area, will not be engaged upon because it will be too far away. It will be out of the range for the defense coordinate range. Yeah. So now we're getting a bit into the core of the air-to-ground dispatching mechanism. So the dispatcher is nothing more than a prioritization mechanism, which squadrons it will launch and will command to engage upon detected targets. Now, depending on the target composition, there will be different defense task types that will require also different squadron types to be set up to engage the right targets. The air-to-ground dispatcher defines 3 task types that are possibly being defined depending on the tactical situation. When the target area has radar emitting units, then AC tasks will be commanded. When a target area is close to friendlies, then a close air support task will be defined. And when there is no enemy close by and no unit within the target area is emitting radars signals, then a battlefield air interdiction task will be defined. And those task types are important because they will require different weapon composition that is required to attack the ground areas. So for radar emitting units, you'll probably need precision weapons that will lock onto those emitting radars to eliminate those targets. For a close air support, you will also probably need precision weapons not to damage your friendlies and to be very efficient in eliminating the close by enemy units. The BAI may allow you to use a broad range of weaponry in all the other cases. Because an air-to-ground defense system has a very broad range of weaponry available, there is a very important parameter, and that's called the overhead parameter within the defense mechanism. Depending on the target area that is being detected containing enemy units, you'll need that overhead parameter to actually specify how many aircraft will actually be commanded for engagement towards that area. And in this example, the squadron overhead of 0.50 would define that you would actually dispatch one defender per 2 enemy targets that are detected. In this case, you'll engage 4 defenders to this enemy target area and 1 defender to this enemy target area. Now, because aircraft have multiple weaponry loadout possibilities, the 0.5 parameter is highly exaggerated, and for example, for helicopters, a 0.25 or even a 0.20 would be sufficient, because one helicopter probably can eliminate a high amount of ground targets on its own. The overhead parameter is also important because you want to control very carefully your resources that are available within the squadron. Another property is the patrol zones, because you don't want to dispatch your aircraft for defense from the airbase in most of the time. So patrol zones are, let's call it, strategic hot areas where you will make the squadrons patrol within the area, and once an engagement is required, they will be commanded by the command center to engage upon the target areas. As a result, the engagement will be much faster, but you will have to make sure that your patrol zones are within considerable distance from potential target areas, and not too close or not too far, or your engagement action will become either too soon or too late. The following is really important. I've been really trying to model the air-to-ground defense mechanism to really take care of your resources. The default built-in defense mechanism of DCS World is not very effective. Even if you have multiple units within a group, the airborne squadron units will start engaging an enemy area, and once they have engaged, they will start flying around chickens within the area. So what I've built is I've built a mechanism where enemy units will actually engage from a safe distance and will return to the safe distance once they have attacked one unit from the enemy area. And this allows or facilitates a much safer engagement model, but might be a bit more slow. It's a trade-off that I've made, and I think this mechanism will really help and will really create the realism of your engagement scenarios. So when your task type is SEED, then the aircraft will engage from 25 kilometers from the target area. When your task is CAS or BAI, but airplanes, they will engage from 10 kilometers from the target area. And if you got helicopters, then those will engage from 5 kilometers from a target area. Yeah. Once the unit has been eliminated, then the aircraft will return back to safe distance for the other round. And this will really help you to make your air-to-ground defenses more efficient. The other parameter that you can play with is the grouping of defenses. Because DCS World can engage enemies in a group coordinated fashion, you can actually make your squadrons to be flying within a group formation. The maximum is 4 and the minimum is 1, but also 2 and 3 are possible. Squadron takeoff happens from air bases. As already explained, squadrons are allocated to an airbase. So you have air bases of different types. You have normal air bases, you got FARPs, and you got carriers. There are different takeoff patterns that you can apply. You can take off in the air, meaning that the aircraft will be spawned directly in the air near the airbase. On the runway means that the aircraft will actually be spawned directly on the runway. Hot start means that the aircraft will be spawned with running engines at a parking spot. And cold start means that the aircraft will be spawned with cold engines on a parking spot. So the spawning in the air, spawning on the runway, will be rather fast in terms of time. A hot start, let's call it medium, and a cold start, let's call it rather slow. Because you have different takeoff methods, there is also a certain risk affiliated with the method. Why? Because the aircraft spawning at parking spots will have the risk that, because you'll have multiple aircraft being spawned and taxiing at the airbase, that they might be damaged and that they may clutter the airbase, meaning your airbase will become inoperational. So when you spawn aircraft within the air directly, then there is a really low risk that your airbase will become cluttered. If you spawn him on the runway, you'll have medium risk, and if you spawn him in parking spots, you'll have a rather high risk that your airbase will become inoperational. But because you have your aircraft being spawned in multiple, let's call it takeoff patterns, there is a wow factor, meaning that when you spawn them at the airbase, well, you won't see any aircraft at the airbase, which is rather boring. For pilots, I mean human pilots, yeah? While if you have them hot started and cold started at the airbase, you'll see the animation and the realism will be higher. So it's depending on the mission designer, what kind of mission that's being built, but I really created this template to actually make a careful choice on what pattern you want to use, what is the wow factor that you want to have in place, and what's the risk and the time requirements that you have from having these aircraft being spawned from your airbase. Now, in order to minimize the risk of the spawning, there is a queuing mechanism that is being implemented within the air-to-ground dispatcher, so that the risk of a airbase cluttering is minimized. I'm going not now in detail on the queuing, but just know that queuing exists, and I'll make a separate video to go in detail on the queuing. Yeah. Also for the landing, you have different landing patterns, and depending on the landing pattern, you have the duration that it will take to make that airplane back available for another defensive action. So it needs to land, so you can land near the airbase, meaning it won't land at all at the runway. So when it's near, it will actually become back available. You can make it land at the runway, so once it touches the runway, it will disappear from the mission, or at engine shutdown, meaning it will taxi completely to a parking spot and do an engine shutdown. So again, there's a risk here. The latter is the higher risk. The first one is very low. But of course, there's a different wow factor. Maybe you want to have your aircraft that have landed really to be taxiing to the parking spots for engine shutdown. So this concludes a bit this first introductory video on air-to-ground dispatching. I will now go into a short video demonstration that explains you all these components. Okay, so here is now a very simple mission. You got a couple of FARPs here, and you got a helicopter template that has been defined as a KA-50, set up with a payload for CAS that is going to be used. So I've started the mission, and you'll see that I got my tactical overview here showing the targets, and there's a new element here compared to the air-to-air, is called the queued aircraft launches section. I'm going to speed up a bit, so this aircraft is going to fly around, and you see immediately that now already areas have been defined with some target composition. And let me show you this one. So there's a seed area that has been defined, area 2, and there's a KA-50 that is being launched at the airbase here. Let's move on a bit further. So the aircraft is progressing. Now, because the aircraft is now close to the other enemies, a lot of new areas have been detected. And because they are rather close to the friendly, all these are being defined as close air support. Note the seed here is because of this enemy here, which has a radar emission unit. Yeah. The enemy is flying further around. It will detect more targets. And because of the close air support, you see here the queuing that is currently ongoing. And you see here a couple of aircraft that are being dispatched towards the enemy area. I've set up a range of around 10,000 meters. 1 kilometer around the area, so there are quite a lot of areas being defined right now, but it's just the first version. So you see these helicopters flying towards the target area for engagement. Interesting here to look at will be that the helicopters that are going to engage the enemy, they are going to engage it from around, rather close, yeah. So they will engage right now. Well, I'm not sure whether that, it's going to go there, and it will return. This one as well. Yeah, it was already rather close, so this one will attack a bit further. I mean, you want to make sure that your area range is rather larger, so that you won't get this kind of situation where you've got a close clustering of enemy targets being engaged by a lot of individual helicopters. You want to have them large enough, like 5 kilometers or even 8, so that there is a well-defined target area composition. Yeah? And I really encourage you to play with these parameters for the moment. In the meanwhile, our seed helicopter is flying towards the seed area. And you'll also notice that once a target has been eliminated, that attacking helicopter will fly back into safety distance for the next round of attack. And this will really spare the amount of resources that are being enabled. The system won't be perfect, but it's at least a much better than the actual out-of-the-box defense mechanisms that are available within DCS World. I mean, helicopters start flying around like chickens around the battlefield, and this will be much more efficient. So I hope you find this useful, this new module, and I'm gonna be making in the course of the next week or weeks further modules to actually start diving into the flexibility that this air-to-ground defense mechanism provides. Now, before I stop the video, let me get into the script a bit on how this was made and how this looks like. So here you have the script. So I am setting up here a set group to define the reconnaissance vehicle group that will detect the targets. Then I'm setting up a detection areas class where I'm using the detection group, and I had here 1000 meters as a range. Then I'm setting up the air-to-ground dispatcher, which is nothing more than one call taking the detection areas as a parameter. So I'm passing here the detection network, and the air-to-ground dispatcher will work. Then I'm having a defense coordinate that I'm adding, and I'm adding this defense coordinate from the location of the headquarters. Find group name. So I'm here returning the coordinate of the location of the of the headquarters. Yeah. There's a new API defined called add defense coordinate to add defense coordinates. My defense reactivity is set to medium, and I'll explain in the next video a bit further what all these things mean. I'm having a defense radius of around 100 kilometers around the defense coordinates. I'm setting the tactical display on. And then here I'm defining the squadrons. Now, different from the air-to-ground, from the air-to-air defense or dispatcher, you will have now different squadrons with different task types. So for each squadron you need to set a task type. Set squadron seed, set squadron's CAS, or set squadron BAI, because of the different air to target compositions that can be there. So for seed tasks, you want to engage, and what I'm doing here is I'm taking off a parking hot spot at makeup seed for the makeup seed squadron at the airbase makeup, using the template CCCP K50, which I'm reusing everywhere actually. Then I'm setting up a CAS squadron, same thing here, but here I'm passing the name of the FARP. Let me show you that a bit so you don't get confused. So these FARPs here, they have a specific name. I'm gonna quit here just very quickly, get into the editor quickly. These FARPs, they have a name. So in this case CAS, in this case seed, in this case BAI, and this is exactly what I'm passing here, the name of the air bases. And having different takeoff characteristics, different overhead parameters. So here I am using an overhead of 0.25, meaning that each airplane will attack about 4 targets that were detected. If you have a larger detected group of more than 4, then 2 helicopters or 3 helicopters would be dispatched for attack. And I'm setting here a takeoff interval, and this is the actual takeoff interval that's being used for the queuing, but for that I will get into a bit more later. So this concludes my video, and I hope you enjoyed it, and see you in the next video that I hope to make very soon. Bye bye. For defenses, I got a couple of enemy units spread out over the battlefield here that are being detected by recce units on the ground. I got one here, and I got one here, and I got a friendly unit here located to emulate the CAS or close air support defense mechanism. So the air-to-ground dispatcher will start defending the targets around the command center, and that's where my defense coordinate will be. And for the moment I've configured a very aggressive defense mechanism, meaning any detected target from a recce will be engaged upon rather immediately. The other reconnaissance that I have here is an airborne one, and it will start flying around here across the attack perimeter, detecting the targets gradually. Because the ground-based, they will have limited visibility over the battlefield, and not all of the enemy targets will be detected. So let us get into the actual simulation here, and let's play.